the 3.3 slope and graphs of linear equations. So let's start off by talking about the slope of a line. If you think about slope of a mountain, it's how steep it is. Okay, so think of slope as the steepness of a line on a graph. Okay, so a line will always go through at least 2 points. A line actually has infinite amount of points, but if we can find 2 points on that line, let's say ordered pair x1 comma y1 is this point, and ordered pair x2 comma y2 is this point. We can find the slope between those lines by determining the change in the y, so how much it's rising by subtracting the y's, and then the change in the x values, so subtracting the x values. All right, so we have this new equation. M stands for slope. And we take y2 minus y1 in the numerator and x2 minus x1 in the denominator. Slope is often thought of as rise over run, so sometimes it may even be easier to just count how far up or down you're going. And then your bottom number of the run is how far left or right you have to go. And because we read books from left to right, we also read graphs from left to right. So you find that leftmost point and you count the rise over run from the left point to get to the right point. So if we're thinking about that formula for slope, what I do every single time I solve these problems is I label. So I want to find the slope of this line. This line goes through the point 1, 2, and 4, 5. So I go through and I pick out my x and my y's. X comes first, y comes second, and this is the first ordered pair, so I'm going to give these 1s, and this is the second ordered pair, so I'm going to give these 2. Now that I've labeled, it becomes easier to plug in my values. So y2 minus y1 would be 5 minus 2, and x2 minus x1 would be 4 minus 1. Simplify the numerator to 3 and simplify the denominator to 3. So 3 over 3, I'm rising 3 and I'm running 3. The slope you could also write as 1. It simplifies to 1. Okay, so it is a positive 1. Let me move this over. So you can see here that they graphed the point 1, 2, and they graphed the point 4, 5. And if you count the rise, it'd have to go up 1, 2, 3 from this left point. And then to get to this right point, you'd have to go right 1, 2, 3. Okay, so up is always positive and right is always positive. Just like in quadrant 1, all of these numbers are positive when you go up. They're positive, and right, they're positive numbers. So let's find the slope. Notice how this is a positive slope. Okay, a positive number, a graph is going to look like an upward direction from left to right. Let's look at the bottom one. Find the slope in the line through -1, 4 and 2, 1. So again, I'm going to label because it helps me keep everything straight and make sure I'm plugging it in correctly. Because on subtraction, order does matter. It makes a difference. So this is an x and a y, x and a y. This is from the first ordered pair, and this is from the second ordered pair. y2 minus y1 becomes 1 minus 4. x2 minus x1. Notice how I wrote minus and then a -1, just so I'm keeping my symbols or my signs straight. 1 minus 4 is -3. 2 minus a -1 minus a negative is like plus a positive. So that becomes a +3. So a -3 divided by a +3 would be a -1. So here we have a negative slope. And you can see from this graph when they plot the point -1, 4 and 2, 1, we're going down a mountain. Okay, so a positive slope, we went up a mountain. Negative slope, we went down a mountain. So start at the left point, and to get to the right point, you have to go down 1, 2, 3. Down is negative, just like we got a -3 here. And then we went right, 1, 2, 3, and right again is positive. If we had to go left, it would be another negative. Okay. A couple more. Find the slope of the line through 1, 4 and 3, 4. So we can do our fancy little equation again. And I want you to find for me the slopes of the top problem and the bottom problem. So this one and this one for me. Okay, on the top equation, you had 4 minus 4 and then 3 minus 1, so you got 0 over 2. And on the bottom problem, you had 3 minus 1 over 3 minus 3, so you had 2 over 0. So these are completely different answers, right? If you typed in your calculator 0 divided by 2, it's going to pop out as 0. Okay, so this one has a slope of 0, but if you typed in your calculator 2 divided by 0, it's going to spit out an error. The reason that this is an error is we can't divide by 0. So this slope is what we call as undefined. Let's look at the graphs. If I were to plot the point 1, 4, and 3, 4, I'd have a horizontal line here, a straight line over across. Okay, so the slope of a horizontal line is 0, right? There is 0 slope. It's not steep at all. If I were to plot this point, 3, 1, and 3, 3, it'd be a vertical line, and that slope is undefined. I can't find the slope of a vertical line. Okay, the slope of a flat line is nothing, it's 0, but the slope of a vertical line is undefined. Know the difference. Okay, we're going to use slope as a graphing aid. And the most popular equation for a line is y equals mx plus b. This is called slope-intercept form. And using this, we can plot a line instead of plugging in different x values and finding the y values and then plotting those points like we did last section. That was a lot of work. So y and x are variables that we never plug in for. But m and b we do substitute in. M stands for the slope, and b is the y-intercept. Remember, the y-intercept is a point. It's going to be x value of 0 and y value of b, depending on where it is. Okay, we already talked about a slope that's positive is going to be rising from left to right. It's going to be up and down. And a negative slope, we talked about how it's going to be falling from left to right, so up and down. A horizontal line has 0 slope, and then an undefined slope would be a vertical line. So for instance, this slope here, I can already see that it's going to be negative because it's falling down. We're going down the mountain from left to right, just like we read a book left to right. Let's start by graphing this equation. I can tell that it's in slope-intercept form because it's y equals a number times x plus or minus another number. So we can actually go ahead and pick out the two variables that we know, our m and our b. M is that number in front of x. So the number in front of x here is 2/3. M again stands for the slope. B is the number tacked onto the end. So that number back here is a positive 1. That's the y-intercept. Which one of these is a point on the graph? Is the slope a point that I can plot, or is the y-intercept a point that I can plot? It's the y-intercept. It's a point, right? This is the point 0, 1. 2/3 is not a point 2, 3. It tells you how steep your line is. So when I go to graph this, I'm going to plot that y-intercept on the y-axis at 1. Okay, so the slope is saying, hey, this line is having a rise of 2 and a run of 3, and they're both positive. Okay, and since they're both positive, that means the rise would be going up and the run would be going right. So I want to go up and right, 2 and 3 respectively. But where do I start? Well, one thing I do know is that this line has got to travel through this y-intercept. So if I start at the y-intercept and I rise 2 and I run 3, I've just created a 2/3 slope that goes through that y-intercept. Up 2 and right 3. And I can connect those dots. I really only need 2 points to plot a line. Okay, so this line matches this equation. What happens though when it's not in this form? It's not y equals a number times x plus b, right? Y isn't by itself, so I need to get it by itself. I need to move this positive 12x away, so I'm going to subtract it on both sides of the equal sign. Those would zero out. I can drop down my 3y. And remember, these aren't like terms, I can't combine them. So typically we want to write our x value first, so it's a negative 12x, and then it's a positive 6. But y still isn't alone, I need to divide by 3 to 1 those out. And then I need to divide this whole side by 3. So negative 12 divided by 3 is negative 4, and there's an x with it. And 6 divided by 3 would be a 2. So this is the line that I'm graphing. Y equals negative 4x plus 2. Let's pick out our slope and our y-intercept here. So the m is the value hugging the x. The value hugging the x is negative 4. B is the number at the end, a positive 2. If this were to say minus 2, I'd want b to be a negative 2. So let's remember, which one of these is a point? 2 is actually a point. It's crossing the y-axis at 0, 2. Right? It crosses the y-axis at 2. So negative 4 is my slope. That's just one number. It's not a rise over a run. But if you think about it, it is a fraction, right? I can make any number a fraction over 1. So I'm rising negative 4. Negative rise means I'm going down. And then I'm running positive 1, which means I'm going right. So from this red line, I need to go down 4 points. Notice how I'm not going to negative 4 and plotting a point, or going to negative 4, 1 and plotting a point. Negative 4, 1 is not a point. It's the steepness of the line. So if the line goes through this point, this red point, I need the steepness to go down 4 from there and then right 1 from there. That just created a negative slope of negative 4. And it goes through this y-axis. Okay, I want you to go ahead and graph the lines y equals 2x and y equals 2x minus 3 on this same graph right here. Okay, so the red line here, y equals 2x, is technically y equals 2x plus 0. So 0 isn't written there, but that is my y-intercept, and 2 is my slope. In other words, 2 over 1 is my slope. So up 2 and right 1. But I'm starting at the point on the y-axis is 0. So I'm at 0, 0, and I go up 2 and over 1, and I draw my red line. Now the blue line has a slope of 2 also, so 2 over 1, but it has a y-intercept of negative 3. I'm still going up 2 and right 1, but I have to start on the y-axis at negative 3. So what do you notice about these lines? Oh yeah, they have the same slope. And it looks like those are parallel. So we do have that new rule, that lines are parallel if they have the same slope. Okay. Let's graph the next two lines for me. So I have y equals negative 2x plus 4, and then I have y equals 1/2 x plus 1. Go ahead and graph them on the same graph. Okay, if you picked out the slope of the blue line, it'd be negative 2 over 1, and you picked out the y-intercept, it'd be 4. So you find positive 4 on the y-axis, you plot it, and then you follow the slope of negative 2 over positive 1. So negative in the rise means down, positive in the run means right. So you went down 2 and right 1, you connected the points, you got this blue line. Now the red line has a slope of positive 1 over 2 and a y-intercept of positive 1. So you go up to positive 1 because that's the point on the graph, and then you follow the slope positive 1, so up, over positive 2, so right. So you went up 1 and right 2, and you connected those points. Now, those lines are intersecting. They're not parallel, they're intersecting. But more specifically, they're intersecting at a right angle. When lines intersect at a right angle, if you remember from geometry, they are perpendicular. Okay, so if I have two lines, and I want you to check out their slope. One was 1 over 2, and the other one was negative 2 over 1. So something I noticed about those slopes is that they have flipped. Right? The 2's in the top here, 1's in the bottom, 1's in the top, 2's in the bottom. So they flipped. The other thing I noticed is that this one's negative and this one's positive. So anytime that happens, anytime you have a reciprocal, is what we call this, and they're opposite signs, one's got to be positive and one's got to be negative, then we call them perpendicular. Okay, so opposite reciprocal slopes. If you're ever unsure if they're opposite reciprocal, how you can tell is if you were to multiply these slopes and you got an answer of negative 1, when you multiplied them, then they're opposite reciprocal. So for instance, if I multiply these two slopes, when I multiply fractions, remember we multiply the top numbers and then the bottom numbers. So negative 2 times positive 1 would be a negative 2. Positive 1 times a positive 2 would be a 2. Oh my goodness, that simplifies to negative 1. So these are opposite reciprocals. That means they're perpendicular. Now we have a couple different options here. We just want to go through and determine if they're parallel, perpendicular, or if neither, or if they don't meet either one of those conditions. So how can we tell? Well, remember, parallel will have same slope, right? Parallel will have the same slope. Perpendicular will be opposite reciprocal. Neither would just be neither one of those cases. Okay, so they're not going to be parallel. They're not going to be perpendicular, but they may like intersect somewhere, just not at 90 degrees. Okay, so let's look at the first example. Line 1. It has a slope of negative 2/3. Line 2 has a slope of positive 3 over 2. So one thing I immediately notice is that they are flipped. Now I want to check, are they opposites? They're reciprocals, but I need to make sure they're opposites. And yeah, one's negative and one's positive. So these would be called perpendicular. Or you could use the perpendicular symbol, which looks like that. Let's go over here. I have line 1 has a slope of negative 4, and line 2 has a slope of negative 1/4. So those are flipped, right? Because negative 4 is a fraction, is negative 4 over 1. So I flipped it upside down and got 1/4, but this is negative and this is negative. So they're not opposites. Because they're not opposites, they can't be perpendicular. Okay. Are they the same exact slope? No, they have the same sign, but this is 4 over 1 and this is 1 over 4. So it's not parallel, it's not perpendicular. This would be a neither case. This one's important. I like to trick students with this one because they're reciprocal, but they're not opposite. So don't be fooled by that. Let's go over here. I have 3 over 2 is a slope and 2 over 3 is a slope. Hey, they're reciprocals again, but we need to check if they're opposites, and they're not. They're the exact same sign. They're both positive. So again, another tricky one, that would be neither. Okay, and what about here? I have a slope of 1/2 and a slope of 1/2. Hey, they're not reciprocals. They're not opposites, so are they the exact same? Heck yeah, they are. These would be parallel. Or you can use the parallel symbols to up and down parallel lines. Okay, so that's easy when it looks like that. I can immediately tell once it's in slope-intercept form. But what about if it says line 1 goes through the points -7, 0 and the point -3, 8. Line 2 goes through the point -2, -4 and 16, 5. So these are two different lines. And to determine if lines are parallel, I need to look at their slope, don't I? That's what I was doing here in all of them, looking at their slopes. So let's find the slope of line 1. So to do that, remember from the beginning of the section, we need to subtract the y's in the numerator and subtract the x's in the denominator and figure out what this slope is. So 8 minus 0 is 8. -3 minus a -7, so plus a positive. -3 plus 7 would be 4. 8 over 4 could simplify to 2 over 1 or just 2. Let's find the slope of line 2. So again, I want to take my x or my y2 minus my y1 over my x2 minus my x1 minus the negatives plus a positive. 5 plus 4 is 9. Minus the negative is plus a positive. 16 plus 2 is 18. I can simplify that to 1/2. Now I need to check their slopes. Are they the same? Nope. Are they opposite reciprocals? Well, they're reciprocals, but they're both positive, so they're not opposites. So this would be neither. They're not parallel because they're not the same. They're not perpendicular because they're not opposites.